Hi everyone, welcome back. Let's write some more Leetcode today. Today we are solving recover a tree from preorder traversal. So the problem states that we run a preorder depth first search on the root of the binary tree. And at each node in this traversal, we will output d dashes, where d is the depth of this node. Then we will output the value of this node. If the depth of the node is d, the depth of its immediate child is d plus 1. The depth of the root node is 0. If a node only has one child, then that child will for sure be on the left side, meaning it will be the left child. So given the output of the traversal, we want to recover the tree and return its root. So if we look at this example, 1 has a 1 dash, so we have 1 dash here, so the left child is 2 and the right child is 5. Right now we have 2 dashes, so it's at the second level. 4 has 2 dashes at the second level. 6 has 2 dashes and 7 has 2 dashes, so they are also on the second level. So now that we have seen some examples, let's get to how we can solve this problem. So one way that we can solve this problem is that we can use a stack, and we will always look at the root of the end of the stack. If the last element on the stack does not have a left, then we will add the current element to the left. If it does have an element on the left, then we will add the current element to the right. And one more thing, before that, at each iteration, we're going to count how many dashes that it has before that. And if the number of element in the stack is greater than the number of dashes, then we need to continue popping from the stack until the number of elements in the stack is equal to the number of dashes. And then we can look at the end of the stack and add our current elements accordingly. So I think it will make more sense when I go through this example. So let's go over this example right now. So in the beginning, it's an empty stack and the number of dashes is 0. So we just add 1 to the stack as the root node. And now the number is 2 and it has 1 dash before, as seen over here. And since 1 doesn't have a left, so we add to the left. And at each iteration, we need to append itself, so 2. And now the number is 3. It has 2 dashes before. So the number of elements in the stack is still not greater than, so no need to pop yet. And if we look at 2, 2 does not have a left, so we add to the left. And by the way, in the very end of the traversal, we would return the first element in the stack. Now we will add 3, append 3. So now we come to the number 4. It also has 2 dashes beforehand, but stack has a length of 3, so we need to pop from the stack. Now that they are equal, we can look at 2. 2 does have a left, so we add it to the right. So add 4 to the right, add 4 to the right, and append. So now we come to a number 5. 5 has 1 dash beforehand, so that number of dashes is 1. But the stack has a length of 3, so we need to pop from the stack. Now the stack has a length of 2, so we need to pop again. And now that it's equal, and we see that 1 does have a element to the left, so we will add 5 to the right. Add 5 to the right, and then we will append 5. So now we come to 6. 6 has 2 dashes beforehand, so we don't need to pop. And we look at 5. 5 does not have an element to the left, so we will add it to the left. So add 6, add 6. And yeah, this is 5 to the left because these two are the children of the 2 node. And so this is the left child of 5. And then we need to append the 6. And finally, we come to 7. 7 has 2 dashes, so we will need to pop. And we see that 5 already has a left child, so we will add it to the right child. 7 and 7. And now we need to add 7 to the end of the stack. And we will return the first element of the stack as our result. So this would be our result. And the time complexity would be O of n, where n is the number of elements in the traversal input, because we will have to traverse through all the inputs. And the space complexity will also be O of n because of the stack, because the stack can take up to O of n space. So now let's get to the coding part. So first we will initialize the number of dashes, which is 0. And then we will start the stack as an empty stack, and we will use I equals 0 as the initial index. So while I is less than the length of the input traversal, we will continue the iteration. So if traversal of I is a dash, then we will just increment the number of dashes, and then we will also increment the index. Otherwise, we will set another index temporarily. We'll call it j. And if j is less than length of traversal, and j is not a dash, so we're trying to get the number, right? We will increment j. So if that's not equal to dash, then we will increment j. And now we can use the value to do the string slicing, so traversal from I to j. Yeah. And then we will set the node, so tree node of val. So now we'll check if the length of the stack is greater than the number of dashes. If it is, then we just pop from the stack. So stack.pop. And we look at the stack, the last element. If the stack on the left has no element, then we will add to the left. Then otherwise, we'll add to the right. Start left is equal to node. So else stack of -1 to the right is equal to node. So -1 just means the last index of the stack. And afterwards, we can add the node to the stack, append node, and then we will reset the index ij, and then dashes, reset dashes to 0, and in the end, we can just return the first element of the stack. All right, let's see if it works. Okay, perfect. Hope this was helpful. Thank you all for watching. If you have any other questions or comments, feel free to leave it down in the comments section below, and I hope to see you all again soon.